Let's do an MO example for HF. Okay? So here it gets a little different because we have on one side of our energy diagram an H, and that H has an S orbital. Okay, so S orbital, I'll just draw it like that, and that H has one electron. Now let's go over to the F side. F is, we're talking about p orbitals now, and F happens to have 5 electrons, 1, 2, 3, 4, 5 in the p orbitals. It's a 2p5. So it's 1s2, 2s2, 2p5, and those orbitals are the different p orbitals. Okay, so it goes up, down, right, left, and then forward, backwards into the page. Now, how are these going to interact? Well, you'll have a low energy orbital. You can see when the s orbital and this p orbital come together, they'll have good overlap. So here's the s orbital and the p orbital, like that. That's a low energy sigma bond. So it's a sigma. The opposite is true on the other side, where we have an anti-bond like this, and this would be a sigma star, high energy orbital. Okay? Where there's destructive interference. Now, for the other two, these two right here, they're going to have kind of a neutral experience. So they're going to come over in what we call non-bonding. So usually draw it like this, and like that. Gonna have a non-bonding. So we have bonding, non-bonding, anti-bonding. Now we want to fill in the electrons, so let's count the electrons. There's 5, 6. So 1, 2, 3, 4, and then 5, 6. And there we go. There's the MO diagram for HF. If you want to do the bond order, number of electrons in the bonding orbital, that's 2, minus number of electrons in the anti-bonding orbital, 0. See, there's no calculation with the non-bonding. Divided by 2, this has a bond order of 1, or it's a single bond. We know that from Lewis. From Lewis we would draw, and we know in fact it would be a single bond.